Okay, in this final lesson about stoichiometry, we've talked about doing mole-to-mole relationships, mole to mass or mass to mole. And now in this lesson, we're going to talk about mass to mass relationships. Remember, the key is we always do mole to mole. So we might be given an answer in, or our given information may be in mass, which is grams, and we have to convert that and then do a mole to mole, and then end up converting back if they want the answer in mass. We're going to work through on page V, number 43, I believe it is. Okay, so if we work through one together, I think you can see the steps involved, and that will help you do some of the other problems on this page. And again, tell your supervisor or your parent, these problems take a lot of time and a lot of effort, and you cannot try to do 3 pages in one day. In fact, you may do 1 page or even a half a page as a one-day goal and spread it out a little bit. This is a lot of work. You'll probably need to use separate paper for doing these types of problems because they take a lot more room than the space they give you on the page. All right, let's look at the important rule. Remember, we can only compare moles to moles. So if we are given grams for a quantity instead of moles, we first have to convert the grams to moles. Very important. Then we do the normal mole to mole comparison. That's the heart of the problem. That's the real stoichiometry. Do it right there, the mole to mole. If the final answer is to be in grams, then the last step is we convert the moles answer into grams as the last step. And I apologize for my voice. I'm recording this during the week that I have the COVID-19 sickness. I tested positive a few days ago. So I am stuck in isolation, which gives me time to do the videos, but my voice is a little raspy. I apologize for that. Okay, are you with me on page V, number 43? Silver chlorate decomposes to form silver chloride and oxygen. So the first thing we need to do is balance the equation. And I'm looking here, looks like oxygen is the one where we need to do, we have 3 on the left and 2 on the right. So we kind of cross that over and take the 3 and make that a coefficient here and put a 2 out front. So now I have 6 oxygen on the left and 6 on the right. Yay! Now I need to look at chlorine and silver. I have 2 on the left and 1 on the right. Chlorine as well, 2 on the left, 1 on the right. So if I put a 2 in front of the silver chloride, it looks like it balances. Yippee! Okay, let's look at what it says now. How many grams are produced by the decomposition of 480 grams of silver chlorate? So I have over here the silver, the chlorine, and the oxygen, and we are adding those up. Okay, so took it right off the periodic table. Write these numbers down. For the oxygen, I'm sorry, I just rounded it off to 48. 15 .9994 times 3. Okay. Added up 191.32. So that's the number that is going to come up here. Excuse me, down below. Oops, I went too far. 191.32 is the number of grams in 1 mole. Okay? So when we multiply now, the grams will cancel. We'll have 480 divided by the 191.32, and we will get 2.50 moles. Okay? All right, so I ran out of room on that screen, so we have a new screen. And I'm going to take the 2.5 moles that we just found of silver chlorate, put that over 1, multiply it times, so here's the mole ratio. I want to have the silver chlorate on the bottom so that that cancels silver chlorate over here, and we're converting into silver chloride on the top. And according to the balanced equation, it's a 2 to 2 ratio. So I'm going to take 2.5 times 2 divided by 2, which, duh, works out to be 2.5, all right? So that means I have 2.5 moles of AgCl. But the question for this problem said how many grams of silver chloride are produced. So your last step now is you need to take that answer, put it over 1, and figure out how many grams are in 1 mole of silver chloride. And I'm not going to do that for you. You can use your periodic table, look up the silver, look up the chloride, get those two numbers, add them together, and that will be the number of grams in 1 mole. And then we'll take that times the 2.5 moles, okay? So again, this part up here is the key. This is the heart of stoichiometry because we are doing moles to moles. And when we do a mole to mole comparison, that's the definition of stoichiometry, okay? So we started with something in moles. We do a mole to mole conversion. We get an answer in moles. And then for this particular problem, the last step says convert it into grams. Don't leave it in moles, okay? Hopefully by walking through this one, and you can finish this one, it will make sense. And you can work through the other problems on this page. Take your time. And hey, you know, it wouldn't be a bad idea after you do each problem to just go to the score key and check it. Look at each step. The score key actually is laid out very well with all the steps for all of the problems. And I hope you do well finishing this page and doing your checkup. I do have one more short video that I want to do that will give you a little heads up about the last two concepts in this PACE before you do your self-test and PACE test.